Good afternoon, all of you. Am I audible?
Yes, you are.
With the permission of the principal and chairperson, may I start the session? Myself, Arpana Oraon from Department of Geography.
Yes, please go ahead, Arpana.
Yes. Myself, Arpana Oraon from the Department of Geography. I am the host and moderator of the session. Welcome back to the second session of the first day of 5 days online skill development program. There are some basic announcements for the meeting. Requesting you all to kindly mute yourself so that we can have a seamless session. The Zoom meeting room is closed for students, but we are running live on YouTube right now. Kindly interact with us from the YouTube live streaming link, which was provided earlier. The chat box is currently inactive right now on Zoom, but it is open on YouTube, and on Zoom, it will be activated while having the question and answer session. Thank you all just from my side. Honorable Principal and Patron, Dr. Sister Jyoti, Honorable Vice Principal, Sister Shobha, Honorable Vice Principal, Sister Shobha, Honorable Resource Person, Dr. Parveen Zahra, CP Coordinator and Head of the Department, Dr. Devjani Roy, members of the Organizing Committee, faculty members of various departments, participants, students, and my dear colleague. Good afternoon once again. On behalf of the organizing committee of Nirmala College, I extend a warm welcome to the second session of the 5 days online skill development program on basis of GIS, remote sensing, GPS in collaboration with BIT Mishra, sponsored under UGC CP scheme. Remote sensing something which is very fashionable used today, very effectively used today. Remote, that means something which is not exactly in contact, something which is far away. Far away could be something slightly away or even very far away. And sensing means getting information, getting data, getting any input. The input could be something like temperature, pressure, or photograph. On that note, we have with us Dr. Parveen Zahra. Dr. Parveen Zahra has been teaching as assistant professor in the Department of Geography, Nirmala College, since 2011. Prior to joining Nirmala College, she was teaching in the Department of Remote Sensing in BIT Mishra for 7 years. She was also associated with NRDMS projects funded by Government of India while she was working in BIT Mishra. She pursued her master's in geography from Ranchi University, Ranchi. She completed her PhD on prospects of horticulture in Ranchi district, a geographical appraisal from Ranchi University. She has published 1 international and 7 national papers and presented 7 papers in national seminars. She has organized one symposium on geoinformatic trends and opportunities at BIT Mishra and one international and 3 national seminars in Nirmala College as organizing secretary. She has done various professional trainings from IIRS Dehradun, RRSSC Kharagpur, EduSat based training on remote sensing, GIS, and GPS. Her area of interest focus upon agricultural geography, forest ecosystem, water resource, and environment. We have really various things to learn from her. Now I would like to request our resource person, Dr. Parveen Zahra, to introduce the session on basic concept of remote sensing. Over to you, Dr. Parveen, ma'am.
Am I audible?
Yes, ma'am, you are audible.
Okay. A very good afternoon, everyone, and warm welcome to our honorable and dynamic principal, Dr. Sister Jyoti, who is always a source of inspiration for us. Vice Principal, Sister Shobha, our head of the department, Dr. Devjani Roy, my colleagues, and my dear participants. This is the fifth session of 5 days online skill development program, and my topic is Principles of Remote Sensing. I think it is very much clear. Slides are very much clear.
Yeah, they are clear.
My topic is Principles of Remote Sensing. And in this session, I will try to cover these topics. That is definition, its principle, remote sensing processes on stages, its stages characteristics of electromagnetic radiation with atmosphere, with Earth surface features, spectral reflectance and application. So first we will discuss what is remote sensing. Remote sensing in the simplest word means acquiring information about an object without touching the object itself. We can understand this mechanism with a simple examination. Example, when you are looking through a window and gathering information about the object located far away, in this case, your eyes act as a sensor and the object or the landscape features are the target which are being sensed. Conventionally, the remote sensing has come to imply that sensor which is mounted on, in this slide you can see, which is mounted on the satellite and the target, the Earth's surface feature, are located remotely apart. That is why it is called remote sensing. And electromagnetic radiation serves as a link between sensor and the object. The sun being the major source of energy illuminating the Earth, this part of energy is reflected, absorbed and transmitted by the surface, and the sensor, it records the reflected energy. So this is the simple technique behind the remote sensing. So this definition given by Caldwell in 1997, the measurement of acquisition of information of some property of an object or phenomena by which recording device that is not in physical or intimate contact with the object or phenomena. Another definition is given by International Society of Photogrammetry and Remote Sensing, adopted a formal definition of photogrammetry and remote sensing. This is an art, science, technology, of obtaining reliable information about the physical object and environment through the process of recording, measuring, and interpreting imagery and digital representation of energy pattern derived from non-contact sensor system. This is third definition given by M. Larry. Remote sensing is a measurement and analysis of electromagnetic radiation reflected from, transmitted through absorbed and scattered by the atmosphere, hydrosphere, and by material at or near the land surface for the purpose of understanding and managing Earth's resources and environment. So we can define in simple word remote sensing. It is a technique of acquiring information about an object by a recording device, that is sensor, that is not in physical contact with the object, by measuring portion of the reflected or emitted electromagnetic radiation from the Earth. Now, the history of remote sensing, it dates back to the early 18th century with the beginning of photography. So photography is the first stage of remote sensing. The Indians started their remote sensing program way back in the late 70s with the launch of Bhaskara 1 and Bhaskara 2 through Indian IRS, that is Indian Remote Sensing Series, and recently on 27th November 2019, a successful launch of Cartosat by has added one more to its constellation of remote sensing satellite that can map the Earth with better accuracy. And so far we have 116 satellites. ISRO, I have used one term, ISRO. What is ISRO? ISRO is an Indian Space Research Organization. It is a space agency of Government of India and has its headquarters in the city of Bangalore, Karnataka. Its vision is to harness space technology for national development. Now, come on this topic, fundamental of remote sensing. The basic principle involved in remote sensing is that different objects based on their characters, structures, chemical and physical properties return or reflects or emits different amount of energy in different wavelength range of electromagnetic spectrum incident upon it. What is electromagnetic spectrum? We will discuss later. Wavelength range of the electromagnetic spectrum. So most of the remote sensing program utilizes the sun's energy. So sun is the predominant source of energy. The radiations travel through the atmosphere and it travel through the atmosphere and selectively scattered. Some are absorbed depending upon the atmosphere, composition of atmosphere and wavelength involved. These radiation reaching on the Earth's surface with the target object. Target objects are trees, plants, means vegetation, concrete construction, concrete buildings, soil, water body, etc. All are target or Earth surface features. Then these objects, according to its nature, absorbs and reflect the radiation. And this is sensor. A sensor used to record this reflected or emitted energy from the surface. This recorded energy is then transmitted to the user. Here you can see from the sensor, after getting the data, it transmits to the station where it is recorded and then where it is reflected or emitted energy from the surface. The whole process, this whole process of remote sensing is It has been summarized into 7 stages. First is energy source or illumination. As you know, the first requirement of the remote sensing to have an energy source with illumination or which provide electromagnetic energy to the target of interest. Second stage of remote sensing is energy interaction with atmosphere. As the energy travel from the source to the target, it means from the sun to the earth's surface feature, it will come in contact with and interact with the atmosphere it passes through. So in the second stage, energy interacts with the atmosphere and the energy on its way from source to the target, that is from sun to the earth's surface, it comes in contact. Second stage. Third stage is interaction of energy with target. Once the energy makes its way, the target through the atmosphere, it interacts with the target depending on the properties of the both the target and radiation. So the interaction of energy with Earth's surface feature, different Earth's surface feature reacts differently to the incident energy. Fourth is recording of energy by the sensor. After interaction of Earth's surface feature, the energy reaches to the sensor where it is recorded. Here you can see after interaction, it reaches to the sensor. This is the fourth stage. Then fifth stage is data transmission and processing. The energy records by the sensor is receiving and processing station where data are processed into an image that is in hard copy or soft copy. So in our country, in our nation, NRSC, that is National Remote Sensing Center, has reception station at Shadnagar near Hyderabad for acquiring data of Indian remote sensing satellite. Then fifth stage is image processing and analysis. The processed image is interpreted and extract information about the Earth's surface. And seventh is application. The extracted information is utilized to make decision for solving particular problem. Thus, remote sensing is a multidisciplinary science. Why? Because it is a combination of various disciplines such as optics, that is scientific study of the light, photography, computer, telecommunication, electronics, and satellite launching. Now, what are the advantages of remote sensing? So first advantage is its synoptic view. Because in remote sensing, the data are captured from a particular height. So it always gives us a synoptic view. It means if we are taking picture from a particular height, so it gives synoptic view. And what is the advantage of synoptic view? In synoptic view, the surface features are always in their true spatial relationship. That's why we use drone also, so that we can get synoptic view. So this geostationary satellite are located at high altitude at 36,000 kilometers away above from the Earth's surface. So features are the size of the Earth's surface feature are very small, but in their true spatial relationship. Next is accessibility. Remote sensing process made it possible to gather information about the area where it is not possible to do ground survey, like in mountainous region, foreign area, snow-covered area, or during extreme weather condition. Also, we can access the data. Third is time conservation. This technique saves our times and effort. Then fourth is multidisciplinary application. The data gathered by the remote sensing process can be used in different disciplines like geology, forestry, land use, water pollution, the deduction, flood mapping, then flood mapping and monitoring, hydrology, etc. One more important application, we can say, or advantage of remote sensing, that it gives repetitive coverage when collection of data on the dynamic themes such as water, agricultural field, forest cover, deforestation, urban sprawl, which is very useful for the chain deduction study. We can easily get data before 10 years, 20 years. So we can do a comparative study on these dynamic themes for their change deduction. What is the scenario? What was the scenario before 20 years and what is the scenario in this year or current year? Next, this is the one of the best utility or advantage of the remote sensing. So these are advantages of remote sensing. If it has advantages, so it's other aspect, it's disadvantages. Yes, it has some disadvantages. This method is very technical and expensive. The typical remote sensing analysis and interpretation requires a well-trained image analyst, which needs practice. And the software is also very expensive. Now come on the types of remote sensing. We can classify remote sensing into two groups, that is based on the source of energy and based on the range of electromagnetic spectrum. So first we will discuss about the classification based on source of energy. As you know, sun is the predominant source of energy for remote sensing. So when remote sensing system, it uses the naturally available energy source, that is sun, it is called passive sensor. And maximum remote sensing is done through this passive sensor. But when remote sensing, which provide their own source of energy for illumination, are known as active sensor. Example, synthetic aperture radar, and another example is radar, that is radio deduction and ranging. This is the another example. Second classification is based on the electromagnetic spectrum. On this basis, we can classify remote sensing into three groups: optical, based on the scientific study of light; remote sensing, invisible, near infrared, middle infrared, ranging from 0 to 4 micrometer to 3 to 3 micrometer. We will discuss later the unit of measurement and electromagnetic spectrum. What is electromagnetic spectrum? Second classification, thermal remote sensing of emitted radiation in the range of 3 micrometer to 35 micrometer. Then microwave remote sensing in the higher wavelength from 1 micrometer to 1 meter. These longer wavelengths can penetrate, or it has ability to penetrate through the cloud cover, haze, and dust. Now, what is electromagnetic radiation? In the previous slide, that first requirement for remote sensing is to have an energy source. And the main source of energy is sun. Sun and its interior part, where the hydrogen is converted into helium due to the enormous confining pressure and high temperature under the process of nuclear fusion, which generate huge quantity of heat. This solar energy radiates from the outer surface of the sun, and that surface is known as photosphere because there is the presence of photons. From the surface, From this surface, from the photosphere, the energy is radiated in the form of electromagnetic radiation. Why it is called electromagnetic? Because it moves from the sun in the form of electromagnetic radiation, which travel at the speed of light. And what is the speed of light? That is 3 into 10 to the power 8 meter per second, and if we'll convert into kilometer, then it will be 3 lakhs kilometer per second and takes only 8 minutes 20 seconds to reach the Earth's surface, covering the distance of 150 million kilometers between the sun and the Earth. To understand how electromagnetic radiation is created, how it propagates through the space, how it interacts with the other matter, we have to understand first wave model, because this electromagnetic radiation, it is very much in accordance with the basic wave theory. So what is wave model? According to wave model, motion of electromagnetic radiation, it consists of an electrical field, magnetic field, which are perpendicular to each other. Here you can see. Sinusoidal fashion at a constant speed of light, that is 3 lakh kilometers per second, and perpendicular to the direction of motion. The electromagnetic energy displays the following properties. This is the way how it moves. This red wave is called electric field. It is in sinusoidal, it is moving in sinusoidal fashion. Then blue wave is magnetic field. It is also moves in the sinusoidal fashion. Both are perpendicular to each other. And this purple shade, it indicates the speed of light indicated by C. So from one crest to another crest of the wave peak, this length is called wavelength. Here we can define what is wavelength. It is a distance from one peak to the next, or one crest, or distance between two successive crests, or distance between two successive troughs. This upper part is called crest and the bottom part is called trough. So this is the wavelength, and in this slide you can see different types of wavelength. Next is wavelength. Standard unit of measurement. Here you can see kilometer, meter, centimeter, millimeter, micrometer, and nanometer. And 1 micrometer is equal to 10 to the power minus 6 meter, and 1 nanometer is equal to 10 to the power minus 9 meter. And centimeter is equal to 10 to the power minus 2 meter. Next parameter of wave model is frequency. It is measured as number of wave peak, crest or trough, two successive crest or trough passing a fixed point in a given time. It is called frequency. It is measured in hertz. It is denoted by V. This is amplitude. Amplitude is the height of each wave peak. So here you can see crest, that is the wave peak. Trough, this is the bottom portion of the wave, and this is the amplitude, it is the height of wave peak. Wave model of electromagnetic energy. The relationship between the wavelength and frequency. Wavelength is indicated by the Greek letter lambda. Frequency V through V, and electromagnetic radiation is based on the formula where C is the speed, that is velocity of light. So if we have to calculate the speed of light, then we have to multiply wavelength with frequency. And these are the other formula we can easily calculate. So we can easily calculate the wavelength, we can easily calculate the frequency and wavelength and speed of light also. One important thing is wave frequency and wavelength are inversely proportional to each other. The longer the wavelength, lower the frequency, and vice versa, which you can see in this diagram. This is longer wavelength. So it has lower frequency because it will take much time. And this is shorter wavelengths. So it has higher frequency because it will cross very speedily. So its frequency will be high. Next is electromagnetic spectrum. It represents the continuums, a series of similar items of electromagnetic radiation arranged on the basis of wavelength frequency. There are several regions in electromagnetic spectrum. For convenience, name has been assigned on the basis of name has been assigned to the region of spectrum depending on the behavior of wavelength. Here you can see gamma rays, short wavelength, high frequency, radio waves, long waves, low frequency. This is electromagnetic spectrum. In this diagram, you can see gamma rays, X-rays, ultraviolet rays. These are shorter wavelengths with high frequency. And this small part, you can see with colorful part, it is visible part. We can see with our naked eye. After that, this infrared, microwave, radio wave, these are longer wavelengths and it has lower frequency. Visible part mein you can see after ultraviolet, the violet color comes. Three basic colors are blue, green, and red. And it is its wavelength has been given in nanometer. And if we'll convert into micrometer, it will be 0.4 to 0.7. Now we will discuss one by one its characteristics. Ultraviolet region. Its range is 0.30 micrometer to 0.38. This region, beyond the violet portion of the visible spectrum, ultraviolet radiation is largely scattered by the Earth's atmosphere, so it is not very much useful for the remote sensing. Next is visible spectrum. Its range is 0.4 micrometer to 0.7 micrometer. And these are the subdivisions: violet, blue, green, yellow, orange, and red. The light, this is the light which our eye can detect. This portion of spectrum is associated with concept of color. Blue, green, red are three primary colors. The colors of an object is defined by the color of light it reflects. Why it is green? Because the reflectance of green color is high. Its application is the best capability to penetrate water, identifying geological structure. This spectrum is also used for discriminating different types of green vegetables and identifying the cultural as well as topographical features, and it is very useful for remote sensing. Third spectrum is infrared. Its range is from 0.7 micrometer to 35 micrometer, and wavelengths are longer than the red portion of the visible spectrum. That is why it is infrared, because last portion of the visible spectrum is red. So after that, infrared IR spectrum comes. So it is designated as infrared spectrum. This infrared spectrum has been divided into 2 or 3 categories based on their radiation properties. So first, infrared spectrum, it starts from 0.7 micrometer to 1 micrometer. And it is suitable for identifying the difference in land use, then green biomass, and vegetable and surface water body. Its second classification is reflected IR. Its range is 1 micrometer to 3 micrometer. It can penetrate thin cloud, it discriminates moisture in the soil and differentiate snow from cloud. And the last division of the infrared spectrum is thermal infrared. Its range is from 3 micrometer to 35 micrometer and is the radiation emitted through the Earth's surface in the form of heat and used for remote sensing. So it is suitable for detecting hot target like fire, lava flow, and such other features. Next is microwave region. Its range is from 1 micrometer to 30 centimeter. Somewhere it is 1 meter also. This is the longest wave length used in remote sensing, and it is suitable for sensing crops, canopies of the tree, leaves, useful for determining ice types. And the main advantage of this spectrum is to its ability to penetrate through clouds, haze, and dust particles. Last one is radio waves. This is the longest portion of the spectrum, mostly used for commercial, broadcast, and meteorology. In this slide, you can see these are the spectrum. This is the radiation source. The sun is the predominant source of the energy here. Here, the Earth's re-emitted energy in the form of heat, that is thermal radiation, and it is through the microwave where the microwave remote sensing, it always illuminates from its source of energy, and then it gets back the information. Then these are the electromagnetic spectrum. This is the range from 0 to 3 to 3 micrometer up to reflective IR, then thermal IR from 3 micrometer to 14 micrometer, and microwave from 1 micrometer to 1 meter. I think it is very much clear what is micrometer, what is radio spectrum, what is radio electromagnetic spectrum. Participants are requested to post their queries in the chat box, which we will discuss after this session. Next is electromagnetic radiation interaction with the atmosphere. So, electromagnetic radiation in passage from the source, that is sun, to the Earth's surface, and from the Earth's surface to the sensor comes in contact and interact with atmosphere. So it has to cross twice, from the sun to the Earth's surface and from the Earth's surface to the sensor. The constituents of atmosphere, that is dust particles and gas, affects the incoming radiation. These effects are caused by scattering, absorption, and refraction. So we will discuss one by one what is scattering, what is absorption, and what is refraction, and what is the role in the field of remote sensing of these things. Scattering is the redirection of electromagnetic energy. The amount of scattered energy depends on the size of particles, dust particles, gas molecules which are present in the atmosphere, their abundance, it means their quantity, the wavelength of radiation, and the depth of atmosphere through which the energy travels. There are three types of scattering. First is Rayleigh scattering. Rayleigh scattering, it occurs when the particles, atmospheric particles, that is dust particles, gas, or water vapor, are very small as compared to the wavelength radiation. Example, small specks of dust, gas molecules like N2, O2, oxygen, etc. It takes place in the atmosphere 2 to 8 kilometers above the ground. It means because it is very small in size, so it goes high up in the atmosphere. Second, this Rayleigh scattering is the cause of the blue color of the sky, and red and orange color you have often seen at the sunset and sunrise time. Next is Mie scattering. This scattering occurs when the particles are about the same size as wavelength of radiation. And which are responsible for it? Dust, pollen, smoke, and water droplets occur in the lower part of the atmosphere from 0 to 5 kilometer because it is comparatively bigger in size. So its area is the lower part of the atmosphere. Third one is non-selective non-selective scattering. This scattering occurs when the particle size are much longer than the wavelength. Large dust particles, large water droplets. And this type of scattering causes fog and cloud to appear white and whitest appearance in the sky under haze condition. So these are the three important types of scattering. Sorry, absorption. Second characteristics is absorption. The phenomena occurs when atmospheric constituents, that is dust particles, gas molecules, pollens, etc., absorbs energy, or we can say prevent transmission of energy in the atmosphere. These constituents are more important. And among these constituents, three gases are more important. That is carbon dioxide, water vapor, and ozone. These are more important, and rest are less important. The cumulative effect, or as you know, the ozone absorbs the harmful ultraviolet radiation from the sun. Then carbon dioxide tend to observe radiation in the infrared portion, and water vapor, that is H2O, it absorbs much of the incoming infrared and microwave radiation. The cumulative effect of absorption by various constituents can cause the atmosphere to close down in certain region of spectrum. This is bad for remote sensing because no energy is available to sense. Now, what is atmospheric window? In the certain part of a spectrum, such as visible region 0 to 4 to 0.7 micrometer, the atmosphere does not absorb all the incident energy but transmits it rather effectively. Part of the spectrum that transmit energy effectively are called atmospheric window. So there are the regions in the electromagnetic spectrum for which the atmosphere is transparent. That is, these wavelengths are easily transmitted through the atmosphere, such as visible region, that is from 0 to 4, 0.4 to 0.7. And in this diagram, you can see the atmospheric window and its importance. In the figure, green color portion represents the atmospheric window through which waves are transmitted, and brown portion prevent the transmission of energy due to the presence of CO2, that is carbon dioxide, H2O, that is water vapor, O3, that is ozone, O2, that is oxygen. So this is atmospheric window. The green colors are atmospheric window, and the brown or dark pink color, it prevents the energy from transmission. In this slide, you can get clear picture of the atmospheric window. The first diagram shows the energy source. This is the energy radiated from the sun. It is in 6,000 Kelvin. This energy, after absorbing Earth radiates, it is in the 300 Kelvin. In the long wave form, it radiates Earth its energy. This is the transmission. Second diagram, it shows the atmospheric window, and the shaded or gray part, it prevents it blocks the energy for the transmission. And third is common remote sensing system, which is through the different wavelength region. Means these are the regions through which act as an atmospheric window. So these are the three different diagrams which are associated to each other. This is the source of energy, this is the atmospheric window, and this is the remote sensing spectrum. Important windows, bands, regions. These are the regions through which energy is reflected very easily, and it is very useful for remote sensing purpose. This is important important videos in the microwave region. These are the bands or area through which it allows for the radiation. Then refraction. Refraction is the bending of light ray at contact between two medium that transmit light. It occurs in the atmosphere as light passes through the atmosphere layer with varying clarity, humidity, and temperature. And I think all of you are familiar with this activity during your school days. This is the example of refraction. These are the two medium through which light is reflected. It is the air and it is the water. Now, next is electromagnetic interaction with atmosphere. Radiation that is not absorbed or scattered in the atmosphere reaches and interact with the Earth's surface feature. According to the law of conservation, sorry, by mistake I have written here atmosphere, it should be Earth's surface. According to the law of conservation of energy, energy cannot be destroyed, but it can convert from one form to another form. You can see here the three process. This is incident energy. It is indicated by EI. Some part is absorbed, that is called EA. Some part is transmitted, that is ET. And some part is reflected, that is ER. So incident energy is equal to reflected energy, absorbed energy, and transmitted energy. So the portion of each process depends on the nature of surface, the wavelength energy, and the angle of illumination. All the interaction of reflective region, surface reflectance are most useful in remote sensing application. Reflection occurs when the ray of light is redirected as it strikes at non-transparent surface. The nature of reflectance depends on the size of the surface, irregularities in relation to the wavelength of the radiation, and there are two types of reflection. A specular reflection, if the surface is smooth relative to the wavelength. For example, such as mirror, or we take example of smooth metal or calm water body. This type of reflections are undesirable for remote sensing. It is not used for remote sensing. Next is diffuse reflection. When the surface is rough relative to the wavelength, diffuse reflections occurs, and it reflected almost uniformly in all directions, and it is very useful for remote sensing. This slide we have already discussed. Next is reflectance curve. Reflectance curves of the different Earth surface feature. There are two types of reflectance, that is specular and diffuse reflection we have already discussed. Then reflectance curves for different Earth surface features. Spectral reflectance, which measure how much energy in percentage a surface reflects at a specific wavelength. Many Earth surface feature reflect different amount of energy in different portion of the spectrum. We take example of vegetation. Here you can see this green line, it indicates the vegetation. and this is the wavelength in micrometer. So you can see in this example, chlorophyll of the leaf, it is strongly absorbed in the blue and red portion, but it reflects in the green wavelengths. It is comparatively high in this green part. This range, it is green spectrum. This is blue, this is green, and this is red. So you can see this blue and red, it doesn't allow to reflect, but the green color, it is comparatively high in the green wavelength. Then the internal structure of the leaf act as a diffuse reflector near the infrared wavelength. Here you can see near infrared. So its reflectance is very high in near infrared due to the healthy structure of the healthy leaves. That is why it is high in infrared. And then this is this curve in the other wavelength spectrum. Then if we take water, then this blue color is clear lake water, and this purple shade, it shows turbid or polluted river water. Majority of radiation incident upon the curve on the spectrum or transmitted. Maximum part is absorbed or transmitted. Near infrared radiation is absorbed, but in the visible part, you can see it's a small reflectance. This is turbid water, polluted water, and this is clear water. So this is the reflectance curve for different vegetation, water, and soil. If we take soil example, so this is dry soil, which has only 5% water content, which retain 5%, and it contains 20% of water. And so the reflectance is very high of the dry soil, which has less water content. Then remote sensing application. Each and every sphere is associated with remote sensing. Agriculture play a dominant role in the economy of a country. We can apply the application of remote sensing in crop combination assessment, crop yield estimation, and detection of crop disease. If plant or our cultivation is our plantation is healthy, then its reflectance is little bit different, and if it has some disease or it is not healthy, then its reflectance will be different. So we can easily detect the crop disease. Soil moisture is also determining crop yielding potentials. Then forestry, for the forest cover mapping, forest density mapping, deforestation, map forest fire identification, mapping, and biomass estimation, we can apply remote sensing. Geology, the application of remote sensing is used for mineral resource. Mineral resource like coal, petroleum, gas, copper, zinc, its exploration and exploitation, we can use remote sensing application. Then geohazards mapping like volcanic eruption, landslide, earthquake. We can also use remote sensing in the land use, land cover, natural resource management, urban expansion or urban for taxation and property evaluation. We can take help of the remote sensing in the urban sprawl also, or change reduction study also. Change direction, what is the scenario 20 years back? What is the scenario 10 years back? In the dynamic themes like population, density, like settlement, like forest, deforestation, these things we can apply change detection with the help of remote sensing application. Then wetland mapping and monitoring, then water pollution detection. The previous slide you have seen the difference between the fresh water and the turbid water. And if it is turbid, then we can do some work or research what is the cause and how can we overcome this problem. So thank you. If you have any query, you can ask question.
Am I audible?
Yes.
Yes, ma'am. Thank you, ma'am, for the wonderful session and enlightening us with your valuable knowledge. There are some questions from the participants, and I will be happy to moderate it for you.
Okay. Ask.
Yes.
Lina, you may ask.
Aditya Nand. Aditya Nand wants to know what is the abbreviation of ISPRS. ISPRS.
ISPRS.
RS, yes.
Where he has got this abbreviation? IP.
ISPRS.
Okay. That is, I think, in the definition that I have. Okay. Let me check. ISPRS, that is International Society for Photogrammetry and Remote Sensing.
Okay. Thank you, ma'am. Next question.
International Society for Photogrammetry and Remote Sensing.
Okay, ma'am. Thank you.
Next
question.
No more questions. Lina, you're not audible. Lina, you're not audible.
Yes, ma'am. Shweta Shaha wants to know.
Sorry for intervening in Arpana. Parveen ma'am, can you just stop sharing your slide and you could,
Okay, ma'am.
you could come on a video mode.
Okay.
Thank you, ma'am. Thank you so much.
Now you may ask. Shweta Saha.
Yes, ma'am.
She's our
Shweta
student.
Shaha. Yes, ma'am. She wants to know that how can we find clear sky days by using meteorological measurements?
Pardon? How can we get clear sky?
Sky days by using meteorological measurement.
You're not audible. You're not very much clear. I'm not getting.
Okay, ma'am. She wants to know how can we find clear sky days by using meteorological measurement?
Meteorological measurement.
Yes, ma'am.
So, meteorological measurement for, is it related for weather forecasting? This question is related for weather forecasting?
Yes, ma'am.
So there are different types of satellite with the help of that, because if monsoon is coming, we can easily assess the speed. So it has heavy rainfall due to the monsoon, due to the cyclone or depression. We get these things through the satellite image because we are repeatedly getting information of the satellite of different part of the world. So we can see the movement of the monsoon, southwest monsoon. So with the help of that satellite, we can, or information, updated information we can get from the meteorological department with the help of satellites.
Thank you, ma'am. Next question, I think it is last question from our participants. P. Yashwanti. P. Yashwanti wants to know, kindly elaborate the largest which energy interacts with.
Largest?
Am I audible?
No, you're not audible. Repeat it again.
Kindly elaborate the largest which energy interacts with.
Yes. Hello.
Means she
Inter-
wants to know. Yes.
Hello, ma'am.
Yes.
Intervening again.
Yes,
The
yes.
question is that please elaborate the target which energy interacts
Okay,
with.
sorry.
She's asking about the
Sorry,
target with
extremely
which the
sorry.
energy would be interacting.
Which is the target, or which is the
Yes.
wavelength?
Which is the target with which energy would interact with. She wants to know about the target, I suppose. She wants you to elaborate on the target with
Target
which
means Earth surface feature. Target means in this slide, which I have explained here, target means Earth surface feature. So in our Earth surface feature, the 3/4 part is covered with water bodies, and 1/4 is covered with land surface. So obvious it is a water body.
That is B plus plus 1.
Target is Earth's surface feature through which energy, electromagnetic energy interacts. Am I clear, Yashwanti?
Yes. They are in Zoom, YouTube, ma'am.
Okay. Target means Earth surface feature. And if we take whole Earth, then water body, it covers 3/4 part of the Earth, and 1/4 is covered by the vegetation, land, concrete surface, water bodies, etc. So obvious water body is the largest area.
Thank you, ma'am. I think all questions have been asked.
Thank you, Lina.
Thank you, ma'am, for this wonderful session. And I congratulate for your wonderful presentation. Thank you, ma'am, for your such an informative and detailed session of remote sensing. Its fundamental concepts. We came to know how remote is done. Thank you so much, ma'am.
It's my pleasure.
Thank you, sister. Thank you, sister, for your constant support. Thank you so much, sister, for your guiding us and giving us a platform to organize this skill development program. Thank you all the participants for joining with us on Zoom as well as YouTube live streaming. Thank you once again. Before we wind up this session for the day, there are few announcements that I would like to make. We are hoping to see you all tomorrow for the next session at 11 a.m. The link for the next session will be shared later. Please stay tuned and thank you for joining us. The feedback forms have been shared with all of you in Zoom chat box as well as YouTube streaming chat box and will close in an hour. So kindly do the needful. Thank you once again. With your permission, sister, I would like to end this session.
Okay, go ahead.
Thank you, sister. Thank you, one and all. Thank you so much.